In this problem, we're asked to graph the inverse function. So first thing we're going to do is we're going to take the graph given and we're going to find some points that are on the graph that we can read really nicely. So we have a point right here at 0, 3. We have a point right here at 1, 4. And a point right there that we could read real nicely is 4, 5. The rest we'd kind of have to estimate. So I'm going to go with those 3 points. And to find the inverse, we're going to go ahead and invert the x and the y. We're going to switch them. So the inverse function will have a point 3, 0, 4, 1, and 5, 4. So we're going to go ahead and graph those points. So 3, 0, 4, 1, and 5, 4. And then to check to see if we have it graphed right, remember that inverse functions, that their function composition is always equal to x. So that means they are symmetrical about the line y equals x. So it should be symmetrical right through the line y equals x, which they are. Okay, same thing with this one. We are going to find points that intersect nicely, like here, 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 and here. So we're going to list those points. Now that we have a few points, we're going to go ahead and find the inverse. So switch the x's and the y's. And now that we have our inverse points here, let's go ahead and graph those points. So 4, negative 3, 3, 0, 2, 3, and 1, 6. And then check it. It should be symmetrical about the line y equals x, which it is. If we folded this graph on this line, they would be symmetrical.